Here are some important points that for like charges, Q1 and Q2 will be greater than 0. It is a case of repulsion. For unlike charge, Q1, Q2 is less than 0. It is a case of attraction. So these are the things we already discussed. Electrostatic force is a kind of central force, i.e. independent of presence of other charges except the pair under consideration. So this statement needs a lot clarification. So what is the meaning of this sentence? Suppose here it is a charge Q1 and the charge is Q2. One more charge is there, Q3, and suppose one more is there, Q4. And if we talk about the total force acting on this object having the charge Q1, then Q2 will be applying force on this charge. At the same time, Q3 will be applying the force on the same charge, and at the same time Q4 will also apply the force. Then how these three forces are to be calculated? Here F2 is force applied by second charge, F3 is from third charge, F4 is from the fourth charge. So while calculating any of these three forces, you have to consider just these two charges, ignoring the others. That is what it is said in this statement, that the net force will be affected. Of course, the net force is going to be the vector sum of all these forces. But if you want to write the force F2, then you have to consider only the charge 2 and the charge 1. Just ignore the presence of other two charges. So that is how the forces are to be calculated. Means while calculating force for each pair, you don't have to bother about presence of other charges. That is the point which is the basic of principle of superposition, that you have to calculate all individual forces independently, irrespective of the presence of other charges, and after that take the vector sum to get the net force. The answer will be correct. So net force will be the vector sum of F1, F2, F3, etc. Have you got this point? What is the principle of superposition? Principle of superposition tells that F is equal to F1 plus F2 plus F3 and so on. So what is the new thing about it? That you already know that force is a vector quantity. So how this principle of superposition is telling us something new? So the point is, here in principle of superposition, it is explained to you that calculate each force independently. That means force between a particular pair of charges is unaffected by the presence of other charges. So you have to calculate the force as if no other charge is existing nearby. So that is the importance of principle of superposition. So that is how these individual forces are to be calculated, just by ignoring the others. And then net force, of course, can be calculated using the vector sum of all the individual forces. So that is how the Coulomb's law is to be used. So we will be taking some examples just to apply the formula for now. And later on, we will be discussing more problems which will be with more complications. But at the start, we will take just formula based questions in order to understand the use of Coulomb's law in numerical problems.